Hey guys, it's Chill here. Welcome back to Hardware 3D Tutorial 7. Today, we've got a double feature. We got a fun little topic. We're going to figure out how to add custom icons to our application. And we got another super sexy topic of error handling. Ooh, you're turning me on, Chili. Now, I know, people don't like to do error handling. And if you look on tutorials online about DirectX or OpenGL or whatever, usually they say, in this tutorial, we're going to skip the error handling, but you should definitely do it yourself. And then kids reading those tutorials go, and they just copy and paste the code, and they don't put in the error handling. And then when things go wrong, nothing works. They have no idea. There's no way to figure out what the problem is, and they just give up. So if you want to work with these hardware APIs where one of a million things could be going wrong, you got to check all your errors. You got to give yourself good diagnostics. It's very important during development, and it's also very important when you're going to pass this stuff out to your friends for them to try out, because it might work on your machine and it'll completely bork on their machine. And unless you've got good diagnostics that pop up errors and give you feedback, you won't know why it's not working on their machine. Now we're going to handle our errors with C++ exceptions. They're going to allow us fine-tune filtering of what exceptions we want to catch and what information we can put in different kinds of errors. They will allow us to throw an error from any depth in our code, catch it at any arbitrary layer, and handle it without having to check error codes at every layer in between. So you're going to avoid cluttering your code up with a bunch of nasty error checks. All right, let's get into the code. I've added a couple of files here, chiliexception.h and chiliexception.cpp. And this will define our base exception class that all of our exceptions will inherit from. And chili exception will inherit from std exception because it's just good practice. So we're going to implement the what function from std exception. That's a virtual function. We've got a constructor. Our chili exceptions, they will be capturing two kinds of data: the line number that the exception was thrown from and the file that it was thrown from. And that's the information that we're going to print out from our what. We're also going to have a virtual function for all of our exceptions that gives the exception type name. And we can get the name, get the file, get the origin string, just basically formats the exception type, the line, and the file all together in one string. And that's what will output. Pretty straightforward. Now, there's only one little tricky thing here, and that's the what buffer. So let me talk about that very quickly here. If I can frickin' toggle, you won't let me. Oh, I'm so mad. It's because I'm in the Git history here. I forgot about that. Okay, so what are we doing? Well, when we format stuff, I'll show you here in get origin string. I just use a string stream to format my stuff, and then I output string stream.string. That's pretty simple, pretty clean. Now, for the what string, what doesn't return a string. It returns a car pointer. So that's a pointer to some memory. Now, if you were to create a string stream, and fill it up with data, and then return your string stream.string.cstring, the pointer. The problem with that is this string stream will die at the end of this function, and your pointer will be pointing to dead memory. That's no good. So what we do is inside of our exception type, we provide space for a buffer, the what buffer. And then when we are building up a what string, we build up the stream, then we fill our buffer with that stream. That buffer will live past the end of this function call, and then we return a pointer to the contents of that buffer from our what function. So this will be, and this is going to be, let me just, I can't toggle, what am I doing here? This is going to be available, I put it protected, so this will be available for writing from all the classes that inherit from chili exception. And that's the basic idea. Now, the first kind of exception that we're going to want to have is the window exception. So in, let me just give myself a little more space on the right-hand side here. We include chili exception here, and we do a class exception, inner class of window. So it's going to be a window exception, inherits from chili exception. And, it has a constructor that takes line and file, and it also takes the H result because Windows errors have an error code that's just referred to as H result for whatever reason. And we're going to overload the what, and we're going to overload, this should be override. Well, I got to fix that, don't I? I'll fix that later. But anyways, we override these two functions here, and we've added a couple of nifty functions in here. There's a static function called translate error code, and this will take a Windows error code and it will give you a description string from that error code. So there's some neat Windows API machinery in here we'll look at quickly. Then a function get error code, that's just a getter for the H result. And get error string, which basically just takes the H result stored in the exception, calls translate error code on that H result and returns the string that you get out of that function. Beautiful. Okay. What else do we want? Let's look at the implementations of this stuff. So in windows.cpp, we include string stream because we're going to be using that stuff. And then down here, I mean, this is all just newly added. So we really don't need the comparison view. I'll just open it up normally. And we go down here, Windows exception stuff. Okay, so the constructor, very simple, calls the constructor for base chili exception and also initializes the H result. Great. What else do we got here? Get type is going to return a different string, chili Windows exception, because that's the exception type for this. There's a string for this exception type. Get error code returns the error code, translate error code, or get error string just calls translate error code on the H result stored in this exception. Now, translate error code is the meatiest function in here. What it does is it calls a function, Windows function, format message. And what format message is it takes the H result and it basically gives you a description string for that error code. And it takes a bunch of parameters. There's a bunch of modes that you can use it in. The mode that we're going to use it in is where it will allocate a buffer for us in memory using a Windows allocation function. So we will pass it a pointer to a pointer, and it will make that pointer point to a newly allocated buffer. And that buffer will contain the error code string. And the return value from format message is the length of that error string. Now, if the length is 0, that means that something went wrong, so we'll just return unidentified error code, construct a string from that. But if the length was not 0, then what we got to do is we've got to take that error code that's in the Windows allocated buffer, copy it into a std string, so that we can free the Windows allocated buffer and return our string. There's a bunch of different ways you can do this. There's a whole bunch of different ways you can format it up, but it doesn't really matter. And the way we're doing here works fine. There's a little bit of weirdness is here. This function normally it's supposed to take a pointer to a string, but if you use allocate buffer, it needs a pointer to a pointer to make that pointer point to the allocated buffer. So you got to do some type coercion here in order to get it the way. It's a little bit of jank, but don't worry. It all works out in the end. So this is a nice little function here. We make it static so that it could even be called outside of this class just for general translation of messages. But it serves our purposes. And yeah, so then the what function for this exception, all it does is it outputs the type of the function, outputs the error code, the error string, and then it outputs the origin string. This is from just the base chili exception. So you get all that information. It's all hunky-dory. Now in Windows.h, we've also added something to the bottom of the file. What is this? Well, this is a little helper macro. Because the magic, in order to get the line number and the file name of where an exception was thrown from, you've got to invoke these two little macros here, these two babies. And it's kind of annoying to type all this out every time I want to throw a chili Windows exception. So I just create a little macro that will expand twinned except to window exception line file H result. Beautiful little macro here. I'm not normally a big fan of macros, but I will acquiesce for these exception deals. So now we've got our exception types defined, but we've got to actually catch those exceptions somewhere. Now, when we're writing a program, we might want to capture exceptions at different levels, different layers, maybe handle them and recover from errors at some time. But at the very end of the road, we want to catch any exceptions that escape to the top level and basically just end the program and display an error message. So that's what we're going to implement here. So around our code, around our main code here, we're going to put a try, and we are going to catch. We're going to catch different kinds of exceptions. First, we try to catch a chili exception. And if that is what we get, we open a nice little message box with the information, and the title of the message box will just be the type of the chili exception, the type string. If we don't have a chili exception, we catch all standard exceptions, and we will output their what string, and we'll output the title as standard exception. And if we get just any kind of exception, we don't know what kind it is, we just put a message box, we say unknown exception, no details available. And yeah, this message box function, it's just a simple Windows API function. It'll throw up a message box for you. If you put the handle to a window in here, it will be modal for that window, so you won't be able to click on that window until you dismiss the message box. But because when we throw an exception out here, our window will be destroyed, we don't have any window, so we'll just put up a normal message box. So it doesn't have any parent. And yeah, we can set the styles here. We just want an OK button, and we want an exclamation icon. All right, let's test this out here. Just a little fun. We'll create just a garbage branch at this commit, and we're going to look at our code. Let's go into window.cpp, and let's go into our Windows constructor here. Now, currently our window here is set to no except. So if we want to throw an exception from here, we would just, we gotta remove that restriction on our window. And you definitely, one thing I just want to note here, you don't want to be changing restrictions like that once you have basically published an API or a library, because that'll mess with a bunch of people's code. But we're still in development here, so it's no big deal. So let's just throw an exception from random place here. So we'll go throw, and let's go twinned except, and we'll give it an error code. We can just Google Windows error codes, and we'll find out. We'll find a juicy one here. What do we got? Error arena trashed. That sounds like my jam. I love some trash. So we'll just we'll throw a chili wind exception from here. We'll see what happens. Run this guy. And there you go. You get your chili window exception. Error code 7. The storage control blocks were destroyed. And here is the file, windows.cpp, and here's the line 74, and that is indeed where exception was thrown from. Very beautiful. Now, we could also do that for standard library exceptions like std runtime error. We'd throw that, and this is what we'd get from there. We get less information, obviously, because it's just a standard exception. Doesn't have all the bells and whistles that we've incorporated into ours, but we'll still get some nice information. And if we just throw some random BS into here, we'll get unknown exception with no details available, and that's better than nothing. So there you go. Our exception system is working out fine. And I mean, we could add more to it here. I could also store, for example, a return code, and then in winMain, after we catch a chili exception, instead of returning -1, we could return any return code that was passed in when we created the exception. So we could allow for custom return codes when you terminate on a chili exception. That would be cool, but we don't really need it, right? This is going to be plenty for what we're doing. And then the final thing we do is we actually do some basic error checks for our Windows stuff. So in windows.h, what did I change here? I relaxed the requirement of no except on our constructor, just like I did in that demonstration. I also added another version of the macro that doesn't take an H result and instead calls get last error to get the last H result, because some Windows functions, they don't return an error code, and instead, if something goes wrong, you have to call get last error to check what the error was. So I just give an extra version of the macro for when you don't pass in an error code. But that's it for windows.h. Windows.cpp, we do a little bit of error checking. Not a super big deal here, but we check to see if adjust window rect failed, and if so, we throw an exception. And we check to see if create window failed. If it fails, hwind is going to be null pointer, and so we throw chili wind last exception. So those are the two places where we can check for errors and catch them. What else did I do? Well, I mean, you might be wondering, just a little bit of an aside here, you might be wondering, Chili, why don't you do error checking in the window class stuff when you're registering the window class? And the reason is is basically because this happens at the very beginning when the program is loaded. So it happens outside of our try catch. So even if we threw exceptions, they wouldn't be caught by anything. So if we wanted to do exception handling for Windows class, we would have to change it so that instead of this singleton being created on the load of our executable, we would have to call a function to create the singleton, and then we could call that function inside of our try catch. But really, you know what? This is never going to fail. I've never had this fail on me before, so I'm not going to go out of my way to make it super perfect. This will be perfectly fine for what we're doing. We don't have to bend over backwards for this error checking on something simple like registering a window class. And the other thing is, well, what about these message handlers, these window procedures, and our handler here? And the answer to this one, it's a little tricky because these are called by Windows 32. If we throw an exception out of here to Windows 32, it'll just crash our program. It is not going to deal nicely with those C++ exceptions. And there's not really that much that can go wrong in these bad boys. So generally, we don't use exceptions in this message handling thing. If you really wanted to use exceptions, what you would have to do is you'd have to do an exception marshalling system where you would catch any exceptions that escape from these functions or that you throw yourself. You would catch those exceptions, you would store them somewhere, and then you would retrieve them from your own code. Because remember, this is being called from Windows. You would have to retrieve them and handle them from your own code. So you could do exception marshalling for these Windows procedures, for the thunk, and for our handler here, but I don't think it's going to be worth it. If it becomes an issue, we can deal with it at that time, but I don't think the juice is going to be worth the squeeze in this case. All right, let's do a little test to make sure our error handling is actually working. So we're gonna sabotage. We're gonna break stuff. Let's give this is the class name, right? So let's give it a fake class name, facbs, and if we run this, let's see what happens. And there you go, Windows exception, chili Windows exception, cannot find window class, and it gives us the error place where the error originated from, the exception. All good. So this is going to be useful for debugging our stuff. Not so much for the Windows API. There's not a ton of things that usually go wrong with this stuff, but it will be very important when we get into the Direct3D stuff. But enough of that stuff now. That's serious bullshit. Let's have some fun. So when we run our window, you'll notice the icon here is pretty boring. The icon in the taskbar is also pretty boring, and the icon of the executable, if you look at it in the folder, very boring. Let's make it more interesting. So what you can do is there's something called resources, and what they are is they allow you to bake resources like images and text into the executable, and then they will be accessible from your code. You can load them, so you can load icons, you can load cursors, you can load all sorts of dumb bullshit. And we want custom icons. So first I've already prepared an icon. You're probably familiar with it if you've done anything with the Planet Chili stuff before, but there is the icon, chili.ico. This icon file contains a bunch of different bitmaps at different sizes, and you can select them. So we've got our icon now. Now we've got to create a resource script that will tell the compiler to build our icon into the executable, to bake it inside there. So we go add resource, and that gives us this dialog box, and we already get the resource script added here, and you can see here we have a header file added that is going to define some numbers that we can use to access the resources when we add them to the resource script thing. Whatever, it doesn't matter. So you can add new resources. You could go in here and you could create a new new icon resource, and then you could draw your own icons for your application. But I've already got icons, so I'm going to go import. We want icon files. Hardware 3D, chili.ico. There you go. Give me that icon. There you go. And this one has 3 different sizes. One of them is a bitmap. They're all bitmaps. Okay. No PNG. But I think you can also have PNGs and icons. Doesn't matter. Doesn't freaking matter. What does matter now is that we've got chili.ico. We got chili.rc. We got our icon, IDI icon 1. So let's close this. Let's go back to our solution. Now let's open up the resource file. I can't do it because stupid thing? It's already open. You want to close it? No. Okay. There's some bullshit with the resource editor. If you try to open in one thing and then it's open in another thing, let's just close everything. Close all documents. Yeah. Save. Yes. Do it. Then we go into here, and now we can open up resource.h. Nope. We can't open it. No, we can't open. Okay. Trust me. It's a little janky, but it works. So this defines a symbol for us, IDI icon 1. I could just call this one IDI. Let's call it app icon. All right, beautiful. And 101, and that is corresponding to the icon that we added there, the chili icon. So now what we're going to do is when we create our window, first of all, when we just build our application now, the executable, its icon will be the chili icon. But we also want that icon to appear in the window when we open the window. So to do that, we've got to do something in our code to load the icon from the executable. So let's go into window.cpp and let's go $include, not how you spell that, resource.h, not capitalized, triggering me already. Now, where is it? It's either going to be going in the class registration or in the Windows creation. And my notes are telling me that it goes in the Windows class thing. So it's going to be hicon and hicon small. These are the two guys where we're going to load our custom icons into. And that's going to look something like this. So let's break it down. There's a function. It's called load image, and that is going to load the image from our executable, the data that's baked into the executable. So it takes handle to the instance. That's how it knows which executable to load the data from. And it takes the identifier for the resource that it's loading. So make int resource will take that defined value and it will do some, I don't know, some bullshit with it to turn it into a number that load image understands. So you got to call this macro on this macro to make some kind of value. Then you have image icon, which I guess is the type of thing that you are loading with load image. And then you have the dimensions that you want. It'll find the one that's closest. So we want 16, 16. And at the end, you have fu load. Really? You can do me like that, Windows. All right. Load image win API. What do we got here? fu load. Yeah, f me, I guess. I don't know. What is it? What is it? So like I said, this one is the type of image. You got bitmap, cursor, icon. And cxcy is the dimensions fu load parameter, one of the following. Created, this is just a bunch of, I guess, options, right? And you can OR them together. So they're all option flags. We don't need them, obviously, because we didn't use them. Didn't use them here. So that's it. That's how you load. So here's the load. 16 by 16 is, I believe, the small one. So let's just copy pasta this. And we'll put that into here. And for the large one, it should be 32 by 32. Yeah, that seems about right. Let's build it. Let's run it. All right, I'm not seeing my beautiful icon in here. What gives? All right, I figured out the error of my ways, sort of. So basically, editing this by yourself in here, just setting it to some random value, doesn't seem to be a very good idea. If you want to change this, you probably got to change it from in here somehow. But I'm not going to figure it out because I don't care. IDI icon 1, you want to be icon 1, you go right ahead. You know what? You win. You win this round. So if we use make int resource on IDI icon 1, and then everyone should be happy. And if we run this, now we've got our sweet ass chili application icon here, and we got a bigger one in the taskbar. You can't see it, but trust me, it's in there. And if you want to jump further down this rabbit hole, you can add all sorts of resources to the application and use them in all places. You can add custom cursors or I don't know, whatever, it doesn't matter. So if you want to do that, by all means, jump in. You've got a little bit of a start now. You know where to start anyways. But this is going to be fine for us. All we want to do is get that sweet chili icon into our executable. that's going to about do it for today. In the next video, we're going to start handling those input messages from the keyboard. We're going to create a nice little system for managing and recording keyboard input and, providing a nice interface to our game code. Until then, thanks for watching. I hope you enjoyed the video. If you did, please click the like button, it helps a lot. And I will see you soon with some more Hardware 3D.